In this lesson, we will cover dynamic versus static MAC address entries. We will go over the concept of aging and refreshing of MAC table entries. We will next go over what exactly is meant by black holing of traffic. And then finally, we'll look at the effect of rebooting of the switch or disconnecting a directly connected cable on the MAC address entries, looking at effects on both the dynamic and static entries. Okay. And then finally, of course, as usual, we will go over questions related to these concepts that get asked in interviews. Dynamic versus static entries. Up till now, whatever we have covered falls under the category of dynamic entries. Why do we call them as dynamic entries? Is because whenever a switch receives a frame, it checks the source address field, and if that MAC address is not in the MAC table, it learns it. So this is what is known as dynamic entry. You can conceptualize in your mind as having another field in the MAC table and put either dynamic or static against it. Okay. Any of the dynamic entries that get created have by default a timer associated with it. And the value of the timer is 5 minutes or 300 seconds. This timer decrements all the way from 300 to 0. And this whole process of decrementing of timer is known as aging. And if before the expiry of this timer, another frame from the same source, having the same source address, does not arrive at the switch on the same port, then this entry would get deleted or purged. To elaborate further, currently I have this entry in the MAC table and it is decrementing like this. And I've just depicted or picturized it decrementing, but assume that it is going through all the seconds from 300 to 5. It reaches 5 and then it goes to 4, 3, 2, 1. And after that, still if frame has not arrived, then this entry will get purged or deleted. Okay. Now, taking a similar example and introducing the concept of refreshing the entries in the MAC table. So depicting or picturizing here a MAC table with the entry for MAC address A on port P1. Time remaining for the timer is 10 seconds. At this juncture, a frame arrives on the port P1 with the same source address of A. So it checks the frame, source address field, find it to be A, checks at MAC address table, the entry is there. What it does is it goes ahead and resets or refreshes the age back to 300. The timer is reset to 300. This concept is known as refreshing of the MAC table entry. Static MAC entries. Now, these entries are made manually by an administrator. Okay. So we have our topology, and here the entry is, we have an entry has been made by an administrator. Bear in mind, no frame has arrived on the switch, so it doesn't have learned anything. This entry is purely made by an administrator, and that's why it is a static entry. It shows up as static, and rest of the same things are there. So entry has been created. This is a static entry. Since there is no age associated with it, this is a static entry. It does not expire. These type of entries are made for devices that stay connected on a particular port. Classic example would that would fall under this category would be printers. Again, just like PCs, printers also have a NIC card, and that NIC card also have a MAC address. So that is where this will go. And the advantage of creating a static entry is that the switch does not have to maintain a timer for that entry, and that's why it saves on processing cycles. So let's go over the correct and incorrect use case of static entries, how a switch handles and what happens when a correct entry is encountered and then as opposed to an incorrect entry. What is the drawback of that? Looking at the good case, PC1 sends data to printer. Here, replace PC2 with a printer, and the printer has the same MAC address B. So PC1 wants to send data to printer. It creates a frame SAA, DAB. Administrator has already made an entry for MAC address B on port P2, static. So when the frame arrives on the switch, switch does the step one, looks at the source address field, and then does not find the MAC address A in the MAC table. So it learns it on port P1. Next, step two looks at the destination address field, finds that B, checks for the entry for B in the MAC table, finds B to be on port P2, and hence it forwards the port frame out port P2. All is good. This is the case of the correct entry. Of course, here the printer will match the destination MAC with its own MAC, since the comparison is positive, match occurs, it will accept the frame. Okay. Now assume that in this case, what I've done is deliberately swapped the place of the printer, kept the MAC address same as what it was B, but changed the port on which earlier it was connected to port P2. I've swapped the place of the printer and the PC4. But what I've not done is modified the entry on the MAC table. So MAC table still points that the MAC address B is on port P2, which is incorrect. Right? So now when the frame comes in for the printer, same thing happens. Step one, MAC address, source MAC address is learned, MAC table is populated. Good. Step two, it checks for the destination MAC address, which is B, finds B in the frame, checks if B is present in the MAC table, it is present, looks for the corresponding port for B, it is on port P2. So switch relies on the entry on the MAC table, unaware that the printer has been moved here, and it simply forwards the frame on port P2. Okay. PC4 receives the frame, checks the destination MAC address, and compares with its own MAC address. It does not match, and hence it discards the frame. So this results in black holing of traffic. The traffic ideally should have gone towards the printer, which would have been port P4. But since the MAC address is pointing towards its mapping is on port P2, whatever data gets sent to MAC address B will incorrectly be sent out of port P2, and this results in black holing of traffic. The data is black holed. Data or traffic gets black holed. Okay. So this is the concept of black holing. Now, going on and moving to the next step of effect of reboot on MAC table entries. Whenever we reboot a device or a switch, the static MAC entries don't get affected. When the switch reboots and powers up and comes back online, the entry will appear again. But if we reboot, if there is a dynamic entry in the switch, and if we reboot the switch, when the entry would go away, and even when the switch comes up, the entry will not get automatically populated. It will not get populated. It will have to wait for a frame to arrive, and again, we'll have to relearn the MAC address. Effect of disconnecting of cable on MAC table entries. So if we disconnect a cable and reconnect the cable, the static MAC entries don't get affected. Whereas if we disconnect a cable on a particular port, for example, this one is dynamic D, and if I disconnect this cable, the the MAC address entry would immediately get deleted. This will get deleted. And again, if this cable is put back, the MAC entry will not get populated automatically. The switch will have to wait for a frame to come and then repopulate or relearn the entry. So the key takeaways for dynamic entries. Dynamic entries get learned. They have a timer associated with them, 300. They count down from 300 all the way to 0. This process is known as aging. And if before the expiry of the timer, another frame does not arrive with the same source address on the same port, the entry will get deleted or purged. And if there is a frame arrive before the timer gets expired, the entry gets refreshed and the timer gets reset to 300. Dynamic entries get deleted when a switch is rebooted or a directly connected cable is disconnected. Static entry key takeaways. Static entries are made by administrators, and these are for devices that we know are going to stay at one place, so which are not going to move. These entries have timers, which basically you can say never expire. As I mentioned, these are for devices like printers, which don't move. If device is moved, administrator needs to manually update the entry. And if the entry is not made, updated, and the entry remains incorrect or stale entries are there in the MAC table, data will get or frames will get forwarded or traffic will get forwarded to the incorrect port, and that will lead to blackholing, that traffic get wasted. And static entries do not get purged or deleted when a switch is rebooted. When the switch comes up, the entry will repopulate automatically. When a cable disconnected and reconnected, the entry will again be available automatically. Interview questions related to these topics. One should be able to explain the concept of aging and when does timer get refreshed, the concept of aging and refreshing, explain the advantage and disadvantage of static MAC table entries, and explain blackholing of traffic. Explain the effect of rebooting of switch or disconnecting a cable on MAC table entries. In next lesson, we will cover the propagation of unicast streams across multiple switches. We will understand how broadcast frames are handled by layer 2 switches and what are broadcast domains in terms of layer 2 switches. We will also consider and understand the concepts of known unicast versus unknown unicast and how layer 2 switches handle them. And then, of course, for all of these topics, we will go over some interview questions.